So here's what's happening in this problem. The positive critical value is not actually a probability. It is a z-score itself. And so we have to find that z-score. What they used to do is they used to take their test statistic, which is also a z-score, and they would compare it to the critical value. But what we often also do is take some probability we would get from this test statistic and compare it to our alpha. And so what we do here is we compare, the way we find our positive critical value is we take our alpha, um, which is, in this case, what is our alpha? Our alpha is, our alpha is this, right? Because it says, test the claim that the proportion of men who own cats is significantly different than 50% at the 0. Sorry, at the 2% significance level, or 0.02 is alpha. Notice you've got p does not equal to 0.05, right? So that means you're doing a two-tailed hypothesis test, which means this alpha is actually cut in half. So when we find our critical number, sorry, this is our alpha, but when we find our critical number, we're going to use the number 0.01. So to find that critical number, we have two choices. We can look over here. We can look at the probability. This is the clunky way of doing it. Then we're going to use our calculator to do it. We want the probability to be 0.01. So if we look right about here, right there, right about there, those are almost 0.01, right? They're not quite there. And we can see that our z-score is negative 2.3, and we would normally average these two, so our z-score would be negative 2.35. That's pretty clunky because that's an approximation, and we can actually get the exact value. So let's pull up the exact value using our normal inverse. So we want the area to the left to be 0.01. Our mean is 0 because we're on the standard normal, and our standard deviation is 1. And it spits out negative 2.3263. Normally, like, this would be an acceptable answer because it's right, but we're doing a two-tailed test, and so normally we report the positive one. So we would just take this number and make it positive. Another way we can think about this is the area that's greater than 0.99. And so the way that we would find that, and it will give us a positive number here, that's 0.99. So remember, this is going to spit out, oh, there it is. There's our z-score that goes to 0.99, 2.326. So this is our critical value. Our critical value is a z-score. It's not a probability. All right. Thanks for asking.